Okay, so here's part 2 of the 1.7 day 2 notes. We're once again solving absolute value equations. Okay, so what I would like you guys to go ahead and do is actually pause the video and do example number 3 on your own. Okay, let's see what you got. So the first thing is we need to identify if this is an and or an or problem. So we have the absolute value of x minus 3 less than 4. So since this is less than inequality, this is an and problem. So we are going to create two inequalities. The first one is just going to look similar to what we have above. Remember, we get rid of the absolute value bars. I'm going to put the word and in between so I remember this is an and problem. Then the other one is I flip the inequality sign and negate the number, okay? Okay, so now from here, I solve for both of them. On both, I'm going to add 3. So I have x is less than 7 and x is less than -1. Okay, this is an and. Now, I know in the last one I said with and problems, write them as compound inequalities, but I think it's going to be just easier if we don't. So don't worry about doing the compound inequality, but that is something just to think about maybe later on that you are able to do with and problems. So once we have this, we are just going to leave it like this. So I'm going to go ahead and box this. This is what we're going to be working on. So just be careful when we do, or when you guys do your homework assignments. Really pay attention to those inequalities and which way they face, okay? Because that will determine what number you need to put when you input your answer into Schoology, okay? So do not worry about the compound inequality. You can just leave it like this. I'm okay with that. Okay, so now what we need to do is place our numbers on the number line. So I have -1 and 0 is going to be in between. And then I have +7. Now from here, I need to decide, do I have open or closed circles? I have open circles because I do not have an equal bar. Now, as we said, with and problems, we're going to shade in between. Okay, so now from here, I just boop, and now I write my interval notation. Now remember, since we shade in between, we go from the first point to the second point. So think about a segment. You got a starting and stopping point. So our starting point is at -1, and because I have an open circle, I use parentheses around the -1. And on my 7, I also have parentheses. So I have I also use parentheses around the 7 because I have an open circle. Okay. So I go from my starting to my stopping point with that, and that's it. Okay, go ahead, pause the video and try example 4 on your own. Okay, let's see what you got here. So we're going to do the same thing. So we have absolute value of s plus 2 is greater than or equal to 8. So notice this is a greater. So this is an or problem. So we're going to shade opposite directions. So I have s plus 2 greater than or equal to 8, or s plus 2 less than or equal to -8. So on both of them, I add 2 to get my variable all by itself, okay? So, or subtract 2, excuse me. So I subtract 2 on both. So I get 6, or s is less than or equal to -10. Okay, with or problems, we shade opposite directions. So I put this at -10, I have 0 in between, and 6. So because it has an equal bar, both of them are closed circles. And I shade opposite directions, so here and here. And I write my interval notation. So remember, because I go opposite directions, it goes forever in both the -infinity and +infinity directions. So I go from -infinity, remember we always use parentheses around the infinity signs, and then I go to my first point, which is -10. Since that is a closed circle, I use a bracket, I use u. Now I go to my second point, which is 6. There's a bracket because it does have a closed circle, and since my shading goes on forever, to the right or in the direction to the right where the numbers are increasing, that's going to be positive infinity. Okay, let's go and do the next one. We're going to skip this one because I think your next one will be number 7, I believe. Yes, so let's do this. So it's number 5 on your notes, okay? Okay, so here we're going to do the same thing. We create 2 inequalities. So I have 4 minus 2u less than or equal to 8. Now we need to determine if this is an and or an or problem. This is a less than. Okay, so since it's an and, we're going to shade in between. And then I have 4 minus 2u greater than or equal to negative 8. Okay, we solve, so I'm going to subtract 4 from both sides, so I get negative 2u less than or equal to 4. And then negative 2u greater than or equal to negative 12. Now I divide both sides by negative 2. So I get u is, now we talked about this actually in our linear equations, or in our systems of equations unit. So that was our unit 1. What happens when we divide or multiply by a negative? Well, what happens there is that our inequality sign actually has to switch. So we're actually going to have now u is greater than or equal to negative 2, and u is less than or equal to 6. There we go, okay? So now we put this onto our number line. So negative 2 is smaller. Remember, please write this from smallest to largest on your number line. We should know that. Now we have equal bars. So that means our circles on the numbers are going to be closed. And because this is an and problem, we shade in between. Now let's write our interval notation. So we go from the starting to the stopping point, and that's it. So because we have closed circles, we use brackets. I go from negative 2 to positive 6 and bracket there. And there's our answer. Okay, we have one more problem. So I have to backtrack here. Make sure you have this down. And on yours, it's going to be number 6 as well as I have. So I would like you guys to go ahead and do number 6 on your own. Okay, let's see what you got. So first, let's identify this as an or an and problem. We have absolute value of 3x minus 4 is greater than 17. So this is an or problem. Okay. So 3x minus 4 greater than or equal to 17, or, remember we flipped the sign, we gave the number, we solve, so on both of them I add 4, so that gives me 21. That gives me negative 13. And then I divide both sides by 3, so I get 7. Or negative 13 over 3. Okay, so now from there, I put my numbers onto the number line. Now, negative 13 over 3, that's going to be the smaller number. And then we have 0 and 7. Okay, so now we need to determine, do we have an equal bar or not? And I think actually on your problem, if I look at it, this actually should not have an equal bar. So I'm going to get rid of that. So I think on your problem, there's no equal bar. So let me change that on mine. Sorry, guys. Get rid of all of these equal bars. There we go. There we go. Okay, so no equal bars. So going from there, now do we have open or closed circles? Open. Okay. And since this is an or problem, we shade opposite direction. So I go to the left and then shade to the right, so nothing in between. So now from here, we always go from negative infinity to our first point, which is negative 13 over 3. Now because we have an open circle, we use parentheses. Then a u, and I go to my second point, which is 7, and then I go to infinity, and that also has parentheses there. Okay? Okay, make sure you watch part 3. We're going to be talking about special types of inequalities here, okay?